Welcome to our first lecture on gas laws. This lecture deals with the ideal gas equation, PV equals nRT, where P is the pressure, V is the volume, N is the number of moles, R is the universal gas constant, and in this lecture I'm using 0.08206 liter atmospheres per mole K. Your teacher might have you used 8.31 joules per mole K, depending on, but just kind of be careful on this. Temperature is T, of course. The pressure is in atmospheres, and if you use 8.31, it has to be in pascals. Volume, for this way I'm doing it, is in liters. If you use the 8.31, make sure the volume is in cubic meters. N is moles, that's not going to change, and temperature is in Kelvin, and that is not going to change. The key word for using this equation is moles. If you see moles, you're going to write down this equation first. No ifs, ands, or buts about this. So let's look. This is the pressure of, okay, there's our moles. So that clues us in which equation we're going to use. So I've got PV equals nRT. Okay, the pressure, okay, I want the pressure. The volume is in liters, so I'm good there. I've had, okay, don't forget the equals, 3 moles and 0.08206. Now temperature has to be in Kelvin. Well, this is a lab, so we have it at 25 degrees Celsius. So remember, to change Celsius to Kelvin degrees, you need to add 273 to it. Okay, so we've got everything. We've got our unknown, and pressure, according to our little chart up here, will be in atmospheres. Wasn't bad, was it? Well, let's look at another one. What is the volume of a gas? Okay, there's our moles. Of course, we know we're going to use the same equation in each lecture, so it's almost a given. Okay, but when you see moles, write this equation down. Okay, what is the volume? Okay, I got 50 atmospheres. And it says I'm looking for the volume. N is 50 moles. R is always 0.08206. Okay, negative 30 degrees Celsius. So don't forget to add 273 to your Celsius temperature, or else your volume is going to be negative, and there is no such thing. So the volume, according to our little chart up there, is in liters. Wasn't hard, was it? Well, that's because our pressure and our volume is already in our units we need to. But what if it wasn't? What if you were in a lab and your barometer or your pressure gauge is not in atmospheres, it's in millimeters of mercury? So here's one up here. Okay, I got millimeters of mercury. It says how many moles? Okay, there's our key word, moles. PV equals nRT. Okay. You're thinking, okay, atmospheres. Remember, 1 atmosphere is equal to 760 millimeters of mercury. There's our little conversion factor. So, if you see millimeters of mercury, to convert it to atmospheres, I almost said moles, didn't I? I'm going to say 900 divided by 760. There it is, right there. Now we got atmospheres ready to go. Our volume is in liters. 3.6. Okay, I want the moles. There's 206. And then don't forget to change your Celsius to Kelvin degrees by adding 273 to that, and see, so N is equal to moles. I like to write mine out. Well, let's look. Okay, we got a pressure, let's go and write it down. We know that's going to be our equation for this lecture, right? Okay, we got a pressure in millimeters of mercury. Well, remember from this one up here, it says anytime you see millimeters of mercury, you're going to divide it by 750. Okay, it says, my volume's not in liters, but I have milliliters. Remember that 1 liter is equal to 1,000 milliliters. So this is actually what you're doing. You're taking 275 and dividing it by 1,000. But one thing nice about the metric system in milliliters and liters, you can move the decimal place over and still mean the same thing. Okay, this is 0.05 moles. And there's my 206. And I said the temperature. And temperature will be in Kelvin degrees. Now, if your teacher wants you to change it into a Celsius degree, remember to get from Celsius to Kelvin, you added 273. To get from Kelvin back to Celsius, you're going to subtract 273. Well, that's pretty much it. Just remember your units. If you see moles, you're going to use the ideal gas equation. Enjoy.